So this problem is about finding higher order moments for Gaussian, jointly Gaussian random variables that are zero mean. So we start with the random variables being zero mean and their correlation or covariance between xi and xj is given by rij. So we have n random variables x1 through xn. What we are interested is in finding terms like this: x1 to the power m1, x2 to the power m2, etc., xn to the power mn. These moments. So the first result I'm going to show is that if all these exponents add up to odd, then this is uh, this joined moment is zero. So this is the result I want to show first. Expected value of x1 to the power m1, x2 to the power m2, etc., xn to the power mn is zero if sigma mi is odd. And of course, if it is even, it will be something, and that's what we will then compute. So let me show. The easier thing is to show this first. So we start with the characteristic function of these random variables. So e raised to j omega 1 x1 plus omega 2 x2 plus etc. plus omega n xn. Now, if for the Gaussian random variables that I described, this is a well-known expression: omega transpose r omega by 2 e to the power, where omega is this vector of omega 1 through omega n, the same thing arranged in. Notice that this, if you want, you can write it as omega transpose x. And R is a covariance matrix whose ijth entry is Rij and it's non-negative, definite, etc. So you start with R11, Rnn, R1n, etc. So this is a positive definite matrix. In fact, a positive definite. So I'm going to expand both the sides and show that there are only even terms on the exponent of the right side, and that's how we will get this result on this result, even power, or if it is adds up to odd power, that is zero. So the left side, if you look at the left side, this is now e to the power. If you write up each term, omega 1 x1, omega 2 x2, etc., omega n xn. Now each we can expand as a series omega 1 x1 to the power m1 over m1 factorial. M1 goes from 0 through infinity, etc. j omega n xn mn over mn factorial. Mn goes from 0 through infinity. So if we multiply all this together, you notice that there are multiple summations on m1 through mn, then j to the power sigma mi, and divided by this product of this mi factorial I equal to 1 through n. Each of these goes from 0 through infinity. And then the interesting terms, e to the power x1 to the m1, x2 to the power m2, etc., xn to the power mn, multiplied by omega 1 to the power m1, omega 2 to the power m2, etc., omega n to the power mn. So this is on the left side. Let me expand this expression and then equate the two terms. So if I expand the right side, e raised to minus omega transpose or omega by 2 is e raised to minus double summation rij omega j by 2. I goes from 1 through n, j goes from 1 through n. So this is after all the expansion of e raised to minus something. So that can be expanded as summation minus this quantity Rij omega I omega j to the power k over k factorial. K goes from 0 to infinity. So notice that on the left side you have terms like this. So we just need to match it to the right side. So let's expand and see what the right side is. So you can see this term repeats k times. So you have ij, I1 j1, ik jk, and then you have whatever is within the summation. You have such k terms. So if I call this 1, 2 k terms. So the interesting thing to remember is, or the important thing to notice is omega j is there everywhere. So as omega I1 j1, I2 j2, omega ik jk. So notice if you look at each term, you have this coming in a pair. So the exponent power is 2. This multiplied by this, again the whatever it is, exponent power, the total exponent power is 2 plus 2, 4, plus 2, 6. Even if some of them duplicate or exactly the same. For example, if this is omega 1 here, omega 1, that will come as omega 1 squared. But the total summation, so if you expand this, you are going to have some constants multiply omega I1, omega j1, etc., omega ik, omega jk is going to be a general term. Here the power is 2, this is 2, this is 2. Some of them I agree is going to duplicate, but nevertheless, if you look at the expansion on the right side, there is always going to be only even terms. All these are only even terms. So that means on the left side, which is here, these terms, this will only have a value if these terms add up to an even number. In other words, if they add up to an odd number, this must be 0. So we get this result that this implies expected value of x1 to the power m1, x2 to the power m2, etc., xn to the power mn is 0 if sigma mi is odd, is an odd number. So that's that. So now let's look at the cases where that's not the case. In other words, let's say we want to compute x1 squared, x2 squared. We want to compute x1 squared, x2 squared, 3 random variable case, etc. So we know x1 squared, x3 squared, x2 cubed would be 0 because 3 plus 2 is 5, so etc. But these things are add up to, these things are tricky how to do this. So I'm just going to do by example a few quantities, and then we'll see how. So on the left side, we have so let me take the so let me start one by one, and just have to do each case separate. So there are 2 random variables here. So this if you expand this, this is e raised to j omega 1 x1 plus omega 2 x2. Expected value is e raised to minus, this is easy, just we can write out r1 on omega 1 square plus r2 to omega 2 square plus 2r1 to omega 1 omega 2. Notice the 2 nature, even nature, divided by 2. So I'm going to expand to both the sides as we did earlier, like here. We just put the 2 terms here. So this is going to be a double summation, j to the power just two terms. So I'm going to call it, let's say, M1 and M2. J to the power, then expected value of x1 to the power m1, x2 to the power m2, omega 1 m1, omega 2 m2. But what we are interested in is 2 here. But let's look at, so if you just so there are infinite number of terms here, m1 going from 0 through infinity, m2 going from 0 to infinity. So the left side, of course, you can write if you extract the term that we are interested in, which is 2 here, 2 here, this becomes j to the power 4. And by the way, there is also a denominator, which is m1 factorial, m2 factorial. So m1 is 2, m2 is 2. So this becomes 1 over 4 expected value of x1 squared, x2 squared, omega 1 squared, omega 2 squared on the left side. So we have to figure out what's the corresponding term on the left side. So on this side, it is plus 1 over 4 expected value of x1 squared, x2 squared, omega 1 squared, omega 2 squared, plus other terms equal to e to the power minus this quantity, which is r. I will write one more time, omega 1 squared plus r2 2 omega 2 squared plus 2 r1 2 omega 1 omega 2 divided by 2. Now I'm going to expand this. Again, you will see that there are a lot of terms. It starts with 1 plus the term. But what we will be interested in is the square of that term, the second term. This is the term over 1 factorial. This square is minus r11 omega 1 squared plus r22 omega 2 squared plus 2r12 omega 1 omega 2, this whole squared. But within this, there is a 2 here, and then there's a 2 factorial outside. So the term that we are interested in is 1 over 8 because there's 2 squared, 2 here. So this 4 and this will cancel, 4 will cancel, leaving a 2. And if you look at it, we have to square this term. So this term is r11 omega 1 squared plus r22 omega 2 squared plus 2r12 omega 1 omega 2 squared. So I'm going to write it one more time so that way easy to see. r22 omega 2 squared plus 2r12 omega 1 omega 2. So if you expand, that's going to be, keep in mind that we are interested in collecting these terms. So this multiplied by this, I can see I get r11. This multiplied by this, I get r11, r22, here to here, omega 1 squared, omega 2 squared, and here to here. So this comes 2 times plus this multiplied by this. So it gives you omega 1 squared. So that's 4 r12 squared, omega 1 squared, omega 2 squared. There are no other terms which will produce this. So the answer is clear. This is equal to, so here 2 cancels. So this is all terms r11 r22 plus 2r12 squared, omega 1 squared, omega 2 squared. So we compare the coefficients of similar terms, giving us if x and y are jointly Gaussian correlated, then this is r11 r22 plus 2r12 squared. So if this is sigma x squared or sigma 1 squared, sigma 2 squared, r12 is sigma 1, sigma 2, rho 1, 2 squared. So you can write this as in this fashion for 2 random variables if you want. And if rho is just the correlation between x1 and x2, then, and if the rho sigmas are identical, then it is sigma 4 multiplied by 1 plus 2 rho 1, 2 squared. So that was for 2 random variables. Now, just to show this technique, let me do this also for 3 random variables. And so what I'm interested is what is the expected value of x1 squared, x2 squared, x3 squared. So three random variable case, and then we can that way you can proceed to then four random variables, etc. So we start with e to the power j omega 1 x1, e raised to j omega 2 x2, e raised to j omega 3 x3 is e to the power minus omega transpose or omega by 2. And this, if you expand as before, we have done each of this is, so this is expected value of three terms like this, j um, e, j omega 1 x1 to the power k1 over k1 factorial, j omega 2 x2 to the power k2 over k2 factorial, j omega 3 x3 over to the power k3 over k3 factorial equal to, so if you only interested in, remember we are interested in 2, 2, 2. So it is pretty clear we should multiply the square term with the square term with the square term here. So k1 is 2, k2 is, so there are all sorts of terms, but I'm going to look at for this term j squared, j squared, j squared, then expected value of x1 squared, x2 squared, x3 squared, omega 1 squared, omega 2 squared, omega 3 squared. Then there is 2 to 2 factorial, which is 8. So you have this plus all sorts of other terms. But this is all in this infinite series, this is all that interests us. So the question is now we should expand this and see. So the right side is e raised to minus omega transpose or omega by 2. This is e raised to minus double summation omega I omega j rij by 2. I goes from 1 to 3, j goes from 1 to 3. So notice that this is one power. We want here two powers on, so you have terms like omega 1, omega 2, omega 2, omega 3. So it's pretty clear you need to multiply, we need to, when you expand this, of course, this is going to be summation, this quantity to the power k over k factorial. But what, so if you expand, what we are interested is at least the square term over 2 factorial. So this term is omega transpose or omega by 2, omega being this vector. These are vectors. And there's a 2 squared here. And so I'm going to expand this and on the next page and see how. So this will come, if you look at the terms on the, notice that here maybe I did make a mistake because you want omega 1, omega 2, omega 3 squared. So you want three of these terms to show up with power 6. So in a square, you will only get the power, here you have, look at the expansion here, you have square here. So if you multiply one more time, you're only going to get the fourth power. So we want to go to the sixth power. So this is, there is going to be a 1 over 8 term, then a 1 over 3 factorial, then this, which I'll do it in the next page. But what I want to show is that this 8 cancels, and you have a minus 1 to the power 3, which is minus 1. J6 is minus 1, so this cancels with this. So we'll carry forward this one. This is equal to 1 over 3 factorial is 6 multiplied by this thing multiply. I already took care of 2, so just this 3 times. So we have expected value of x1 squared, x2 squared, x3 squared omega 1 squared, omega 2 squared, omega 3 squared equals 1 over 6 double summation Rij omega I omega j double summation Rij omega I omega j and one more time double summation Rij omega I omega j. I goes from 1 to 3, 3 random variables. J goes from 1 to 3 in all of this. So the procedure is simple. You just have to expand, tag along the terms and compare. So I'll do one more so you can see the idea. We just have to expand this out. There is no other easy way. So the terms are R11 omega 1 squared plus R22 omega 2 squared R3. Maybe there are easier ways, which I just don't know. You can do the derivative so many times, but then tag along the terms. Anyway, plus 2R12 omega 1 omega 2 plus 2R13 omega 1 omega 3 plus 2R23 omega 2 omega 3 multiplied by R11 omega 1 squared, same thing, just 3 times R22 omega 2 squared, R33 omega 3 squared, plus 2R12 omega 1 omega 2 plus 2R13 omega 1 omega 3 plus 2R23 omega 2 omega 3. And one more time, R11 omega 1 squared, R22 omega 2 squared, R33 omega 3 squared, plus 2R12 omega 1 omega 2 plus 2R13 omega 1 omega 3 plus 2R23 omega 2 omega 3. All right, so now it's easy. 1 over 6 multiplied by, you just have to see how many ways you can generate terms like this. So let me just do that first here. We want omega 1 squared, omega 2 squared, omega 3 squared. So that you can generate by collecting terms from omega 1 squared, omega 2 squared multiplied by omega 3 squared. So you can see there are such terms here, omega 1 squared, omega 2 squared, omega 3 squared. Many ways you can go, so we'll see that. So that's easy to see. If you pick up omega 1 squared, you can pick up omega 2 squared or 3 squared here. So there are two choices here. For each choice, there you have two choices here. Then once you pick up this, then you just have one choice here. So 2 multiplied by 1. But there are 3 such choices to start with. So 3 multiplied by 2 multiplied by 1. So there are 6 such terms that will give you this product. And then you can have omega 1 squared, omega 1, omega 2, omega 2, omega 3, and omega 3, omega 1. That's another possibility. And there is one more possibility. You can pick up omega 1 squared and then omega 2, omega 3, or from the second one, and omega 2, omega 3 from the third one. Or you can do this on omega 2 squared, then pick up omega 1, omega 3, omega 1, omega 3 twice, or omega 3 squared and omega 1, omega 2, omega 1, omega 2. So you just have to see how many times all this adds up. So let's look at the this one. So if you pick up omega 1, omega 2 here, first of all, you can either do on this, or you can start with this, or start with this. So there are 3 possibilities. For each such possibility, if you pick up, for example, omega 1, omega 2, we can either pick up this or this, 2 options in the next side. And once you decide to, you just have a third option. So for each first on first row, or on the first term, you have three options. Each such term you have two options, then one option. 3 multiplied by 2 multiplied by 1. Except that on each of them you also have a 2, 2, 2 here. So you have a 2, 2, 2, because there is a 2 here, 2 here, 2 here in the expansion. So that on top of that you have another 3, another 2. So that's going to be 8 multiplied by 6. The reason I write it like this is there's a 6 here. So this is 6 such terms involving R11 or 22 or 33. That's what here is. The omega 1 squared, the coefficient is R11. Omega 2 is R22. This is R33. And there are so maybe we need to rewrite each of them, each of these terms separately. Anyway, let me finish this also. Then the next one is so these terms are R12, R23, R31. So there are 8 multiplied by 6 terms, R12, R23, R13. We just went through this. This coefficient is coefficient is in fact 2R12. This is 2R23, and this is 2R31 or 13. And assuming all the random variables to be real. If you bring in complex, you have one more layer of complexity. Now, if you go to the last one, which is omega 1 squared. So if you pick up omega 1 squared, then you have to have omega 2, 3. So omega 2, 3 is just 1, 2, 3. And in the next one, there is another 1, 2, 3. So just 1 multiplied by 1. But first of all, notice that there are, so each such term, there is a 2 here, there is an omega 1 squared, and then when you come to the omega 1, 3, there's a 2 here, there's a 2 here. So there is a 2 here, there is a 2 here. But on top of that, we could have started from here, or we could start from here, or we could start from here. So there are other 3 options when you expand. When you start with this, you get this with 2, 2. This 2, 2 is simply because it just happens to be coefficients. So there is really only one term, but there is another omega 1 squared. You can go here, here, and here. One this thing, here and here. So 3 terms, just omega 1 squared multiplied by 3. So which is true for all everywhere here, omega 2 also. So 3 multiplied by 2 is 6 multiplied by 2. So there are 6 multiplied by 2 terms of this following form. So the coefficient, this is R11. This is actually 2 R23 or 2 R23 squared. 2 R23, 2 R23. So this is going to be, I took care of the 2 here because this is 2 multiplied by 2 multiplied by 3. So this is R11, R23 squared plus R22, R13 squared plus R33, R12 squared. All right, now the 6 cancels, and you get R11, R22, R33 plus, so 6 goes away. 8 multiplied by R12, R23, R13 plus 2 multiplied by R11 R23 squared plus R22 R13 squared plus R33 R12 squared. So I'm going to just write this in the so this helped us with this, and you just have to do this with other terms also. You get finally expected value of x1 squared, x2 squared, x3 squared equals r11, r22, r23, r33 plus 8 r12, r23, r31 plus 2 r11, r23 squared plus r22 r13 squared plus r33 r12 squared. And so that's the answer. Now you can of course simplify special cases. For example, this is sigma 1 squared, sigma 2 squared. So if you can also rewrite this as sigma 1 squared, sigma 2 squared, sigma 3 squared. 1 plus, notice this is sigma x, sigma y, r12, sigma x. So sigma x comes twice, sigma 1 squared comes twice. So this is 8 r12, r23, not r, row 1, 2, row 2, 3, where row is the correlation. Row 3, 1. In other words, each of this we'll write it as row 2, sigma 2, sigma 3, row 2, 3, etc. And the last one here will be plus 2 multiplied by row 1, 2 squared plus row 2, 3 squared plus row 1, 3 squared. And if they are identical, then you get a cubic equation, etc. In other words, if all the rows are equal, this will be 1 plus 6 row squared plus 8 row cubed multiplied by sigma to the power 6. And now you can, so if you want to do 4, you just take 4 random variables and proceed like this. That's sort of the idea. I have the result somewhere here, so I'm just going to let me see whether I can. Before I do that, we can do a similar problem, which is expected value of just curiosity. Not that there is any meaning to this, simply because this adds up to 6. 1, 2, 6. So this should be a non-negative number. Let's see how to compute expected value of x1. Just an exercise, x3 cubed. So we should be taking e to the power j omega 1 x1 plus omega 2 x2 plus omega 3 x3, and if you expand this, it's a if we write it again as a product of 3 terms, each of this multiplied, expanded, and so the term we are looking for. So remember, each of them is going to be of the form j omega, let's say omega 2 x2 to the power k over k factorial. So here you want power 1, here you want, so here you want power 2, here you want power 3. So j would be j to the power 1 plus 2 plus 3, that's j to the power 6. And expected value of x1, x2 squared, x3 squared. So this will be omega 1, omega 2 squared, omega 3 squared. So we just have to look for such terms in the expansion for 3 random variables. And if you on the right side, on the other hand, it will be because we need a distinct terms with three times. So you have to go for omega transpose or minus or omega by 2 three times with a minus sign. So minus 1 to the power 3 omega transpose r omega by 2 omega transpose r omega by 2. Each of this is of the form double summation omega I omega j rij I from 1 to 3 j from 1 to 3. So if you expand that, first of all, let's look at uh, uh, the constants. So we're just taking so this is 2, 2, 2. And by the way, here on the left side, we had, I forgot the constants here. Here you have 1 factorial, 2 factorial, 3 factorial. So if you put it together, this is 2 factorial and 3 factorial. So that's 2 multiplied by 6. And on this side, you have if you expand these terms and compare, I'm just going to write down the results that I have. So first of all, before we proceed, I'll give a little more clue. So we want omega 1, omega 2 squared, omega 3 cubed. So this you need terms like omega 1, omega 2 multiplied by omega 2 omega 3 multiplied by omega 3 squared. So this is, we need terms like this. So that's how we know we need to bring in three terms. And another possibility is omega 1, omega 2, omega 3, omega 1, omega 2. Then you have omega 2 squared, omega 2 squared. So this is omega 1, omega 3, and then omega 3 squared. So again, you need three terms. So the right side will be, because it is three terms, you also have 1 over 3 factorial. So notice that 3 factorial and a 2 will cancel here. So we can write down, so let me just write down here itself, expected value of x1, x2 squared, x3 cubed. So we took the, I mean, there are all sorts of terms. I'm just looking at the expansion on this right side exponent, which is, remember, this is equal to e raised to, each of this is of this form. And so we notice that these are the terms we should be looking for. So omega 1, omega 2, the coefficient is 2r12. Here the coefficient is 2r1, 2r23. And so I can just write down this. So this multiplied by omega 1 squared, omega 1, omega 2 squared, omega 3 squared. This multiplied by omega 1, omega 2 squared, omega 3 squared. So notice this is omega here 2r12, and then 2r23. By the way, there is a 4 here because we took care of this 6. There's a 2 here, 2 here. So I brought the 4 here. And then we also have the last term, which is R33. So And the second term, if you look at here, this, so omega 1, omega 3, again you have 2r13, and then this is one term from the second one, and there is a 3 term, but few terms we miss. So let me go back to this term. So this 2 and this 2 are coming from, because it's a 2 here, there's a 2 here. But then if you look at that, when you pick up this from the first term, there are 2 options here and 1 option here. So this is multiplied by 2 multiplied by 1. And then there are 3 options with respect to, because you could do this or this. So that's another 3. And because it could be, we could, the first term, you can either start with this or this or this. Similarly, if you come here, you have 3 options here, and also the same story here, because you have 3 options to start with, and each option, when you go to the next one, you can either have this or this. If you start with this, if you start with this or this, so another 2. So notice 4 goes out, and the result, if I'm right, so this multiplied by, so this will turn out to be 4 cancels here. So this you get 6 r12 r23 r33, and then 3 r13 r22 r33, etc. I hope this is right. And similarly, you can do for any power of any number of random variables. You just have to tag it along. Thank you.